Hey guys, so this lesson is going to be recorded entirely on the computer with this Google Doc actually. We're going to look at another fun problem today and some surprising connections that these expressions we've been learning have to probability problems. What I'm going to ask again is that you're not actually working ahead quite yet and you follow through with a few things, and then there'll be times where I say, okay, go ahead and do these problems next. So we're going to call it the roll of the dice. And if you're, somebody who likes to have like a kinesthetic learner or something with you and you have a dice available, you're welcome to grab 2 dice and play with them here. But I think we can kind of get the ideas without having to play with them. As you know, it's common in many games to roll 2 dice and you get to move an amount of spaces equal to the total of the first 2 dice. So what I want to have you do first is to fill out the following table for the totals on 2 dice, and then we'll have you answer the questions about it. Your prior knowledge for this will be just addition of numbers, because adding 2 dice up, probability, and for example, let's say we had, 4 red marbles in a bag and 8 blue ones. Right? If we had 4 red marbles and 8 blue ones, what's the probability of drawing a red marble? Well, let's think about this. If there are 4 red marbles and there's 8 blue ones, how many are there in total? There are 12, right? So since 4 out of the 12 marbles are red, the probability would be 4 over 12, which is about 33%, right? 33.3% likely to draw a red marble. So that's just basic probability, and then multiplying algebraic expressions will come in a little later. So what I'll have you do first is I'll have you pause and actually fill out this table, and you can do it directly in the Google Doc or fill it out in your notes. That's fine. And you can answer questions 1 and 2 at least as much as possible. It'd be nice if you get up to 2C anyway. And then we'll come back together and talk a lot about this in a few minutes after you've worked on this. So now that you've looked through numbers 1 and 2 and filled out your table, let's take a look at it together. Now obviously you didn't need color code it. I tried, it's hard to find a variety of colors on here, so it doesn't look super all lined up with the colors, but I did that on purpose because it's really helpful for us to actually look for these patterns here, and hopefully you saw these patterns. So let's start with the first question. How many different rolls are there? And what we mean by that is basically how many squares did I fill in here? And if there are 6 here and 6 here, well, we can see that there's 6 times 6, which is 36. Now, of course, that assumes that each, let's say 6, for example, is different. Now you and I would probably consider a total of 6 as being the same if we're playing a game. But technically a 1 and a 5 versus a 5 and a 1, or a 3 and a 3, or whatever, are different rolls, right? And then which is the most likely roll? Meaning what number is most likely to come up when I roll 2 die? And that is equivalent to asking what's the most frequent number that you see in your table. And hopefully you recognize that that number is 7, right? And how many different ways could we get a 7? Well, you can count them across here and see 6. So out of the 36, 6 of those are 7. So if we ask probability for there, which we could have asked, I don't think I asked 7 down below, but 6 out of the 36, which is actually, if we simplify, is 1/6. So the probability is 1 out of 6 times you roll will be a 7. So let's use that to go ahead and answer our following questions. What's the probability of rolling each of the following? Well, an 8. Well, let's just go ahead and count them up. There are 5 out of 36. So I'll just use an arrow here. 5 out of 36 is my probability of 8. Well, how about a 3? Well, there's two ways to roll a 3. That's it. A 1 and a 2, or a 2 and a 1. So 2 out of 36, if you simplify that, is 1/18. And then at 12, if you look at number 12, there's only one lonesome 12 here, so there's a 1 out of 36 chance. Now, of course, we can convert all of these to percentages and, and then turn it into a percent. I actually just converted these to percentages real quick so you'll have a little bit stronger understanding of how much the likelihood is. So 13.9% of rolling an 8, about 5.6% of rolling a 3, and then about 2.8% of rolling a 12. Now these next ones are interesting because when we say at least 8, what do we mean when we say at least? Well, that means it could be an 8 or a 9 or a 10 or 11 or 12. 12 is the highest possibility. So what we can do here is go back and we can say, okay, well, an 8 is 5 out of 36, but a 9 is 4, and then a 10 is 3, and then 11 is 2, and then 1 for 12. So how many total do I have here? Oh, well, I have 5 plus 4 plus 3 plus 2 plus 1. And if you add those numbers up, you actually get 15 out of 36. And the decimal for that is about 41.7%. So we're pretty likely to get at least an 8, right? So you can go ahead and pause this and do the other ones yourself to make sure that you have an understanding of what we did for part D. Now let's look at these together. Now at most 3 is slightly different, right? That means 3 or less. And since there's a 2 and 2 3s, really we just have a 3 out of 36 chance. And if we converted that to decimals, 8.3%, or we could have also simplified that like I did above, I suppose, and made that into 1/12, of course. And then at least 6. Well, actually, this is nice because we already know there's 15 from 8 to 12, and then we just have to add 5 6s and 6 7s, right? So that's going to be 11 plus 15, which is going to be 26 out of 36. And if we simplify that, 13 out of 18, and the percent for that would be pretty big, 72.2%. Now what I want you to do is I want you to go ahead and finish the next page off yourself, and we'll come back and take a look at that together, and you'll see some surprising connections between those two problems. So I'm assuming you filled out the expansion box here, and of course you could have drawn it in yourself by hand or whatever. As a reminder, Google does have a way to put equations. This is how I'm doing. If you go to Insert, Equation, and then it puts a little box in there and you can do that yourself. So let's take a look at this. I want you to look at something really carefully, and maybe you already noticed this, but look at the exponents on all the terms here and how they're spread out in these boxes compared to the numbers that we got from rolling the dice in the first example. And you notice the exponents are exactly the same and exactly in the same positions. It's pretty crazy. Now, I didn't color code it this time, but you can see that they're identical. Now, here's the crazy thing. If we actually were to say, okay, what's x plus x squared all the way up to x to the 6th, all squared, right? That means we actually multiply it by itself, right? And be careful. Remember, this doesn't mean you just put this squared into everything. It doesn't work that way. You actually have to distribute each with each, like we've said. And that's where this expansion box is really helpful. I want to remind you that these diagonals have like terms. So let's start here. How many x squareds are there? Just one of them. But how many x cubes? Oh, 2x cubed. And then next there's going to be 3x to the 4ths, and then 4x to the 5ths, and then 5x to the 6th, and the highest one we got is 6x to the 7th. And then we have more to go. It's going to be kind of a long one. Then we have 7, not 7, because it seems like the pattern should keep going up, but if you look here, this is the most, and then the 8s actually go back down to 5 of them. So 5x to the 8ths plus 4x to the 9ths plus 3x to the 10ths plus 2x to the 11th, and then we finally just have a single x to the 12th afterwards. So you notice it goes, the coefficient, the number in front goes 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. And then the exponent itself corresponds with the number that I was trying to roll. So it's really crazy. Polynomials can be very useful models or tools for probability problems because of the way exponents work, especially in this case when we have a dice that we're rolling. So that's this important note I put down here. And so just to look at something for a minute, there's a lot of questions we can ask about this. If I could just ask, just from looking at this expression, instead of using an expansion box, let's imagine I didn't use an expansion box, and I asked, okay, well, how many ways are there to roll 9? And you could just look here at the term x to the 9th, and the coefficient tells us how many ways. There are 4 ways. It's a really cool connection between polynomials and probability. So you can go ahead and move on. This one's kind of a quiz, the last one. Which polynomial could be expanded to answer the probability questions about an 8-sided die? And I'm actually going to ask one more question. I'm going to edit this real quick and throw in one more question. In the 8-sided die problem, how many ways are there to roll a, let's say, 9 with 2 8-sided dice? Okay, so what I mean is you want to set up this polynomial and then expand it, and then you can answer this question. And I want you to try to answer the question without using the expansion box. Well, it's fine if you use the expansion box, but also using the expanded form of the polynomial. So you can go ahead and do that, and we'll look at the answers, and then we're done for today. Okay, so let's see how you guys did on this quiz. I'm hoping you might be able to notice you might have been able to notice some patterns and didn't necessarily need to do a full expansion box actually. No matter what though, in the end you should get x squared all the way plus 2x cubed plus 3x to the 4th, just like we had the same pattern, except we don't stop at 6x to the 7th anymore. We go up to 8x to the 9th, right? Because 9 is the highest possible number that I could, or 9's the most frequent, number that I could roll, and the highest possible number would be 16 because 2 8s, right? But the most frequent one, the most ways to make a number would be 9, because you can think about that. Like you could roll an 8 and a 1, you could roll a 4 and a 4, you could roll a